Okay, so we are April 12th, 2021. All right, so last lecture of the semester. And then I guess the last week of Stat 350, we have our final exam on Friday. All right. And then that'll be all she wrote for us. So today we're going to finish up the example that we started last class on adaptive sampling. And then we'll stop with new course material. As I had said on Friday, my goal was to finish new material on Friday, just because typically we sort of because typically it's a week before any kind of test, we cut off the material. So there's no real point in doing anything new after that date. But we just have a little bit to finish up from the adaptive sampling example that we started on Friday. And then after that, we will go through some review and we'll talk about the course material, about the structure of the final, just go over some of the details about the final, the materials that are available to you and these sorts of things. And then if there's any questions at any point regarding the final, a lot of them got asked on Friday, but if you guys have a few other ones or want to confirm something else, then I'm happy to take those questions. And that'll pretty much be it, I think. So we'll start off by finishing up the adaptive sampling idea. So adaptive sampling, as you see here, is an approach very similar to the other approaches that we've talked about in terms of the formula that we're using and the goal of the approach. So we want to estimate some population quantity, say a mean, or in the variance of that estimator. We could estimate the total, this kind of idea. Adaptive sampling differs from the other sampling schemes that we have seen before, as the idea is it as information becomes available, it also becomes included into the estimation scheme. So you can sort of think of it as over time, you're collecting additional information and making use of that additional information. But if you look at it from a fixed point in the future, it's really not all that different from what we have seen in the past, in that you have a set of values, you have a determined sample size after the procedure has sort of come to a close, and then we're using those values to estimate the again, the mean or the total or proportion or whatever quantity it is that you're interested in. So when we talk about adaptive sampling, we talk about this idea of collecting information sort of over a time frame or taking in new information as it becomes available to you. We have an example here of what this could look like. So this is an example where we have a 10 by 10 grid. So this 10 by 10 grid would represent the area from which we are collecting information. Now, in this illustrative example, the data has been manufactured, if you will, or kind of designed by myself and the textbook author to illustrate the approach. These values are, I guess, in some sense made up. So this goes back to a question that was given on Friday, like where did the numbers come from? So all of the values for the Y1 through Y5, these are just values that have been chosen for the purposes of the question. They probably did arise from some previous experiment that was conducted in the past at some point, but I don't have a lot of details on the particular experiment that led to these values. So this, as always, is for illustrative purposes. Okay, so how does this adaptive sampling scheme work? Well, as we talked about on Friday, we have this 10 by 10 grid. So we have, in this case, 100 different observations that would be available to us. Okay, so we can write here, just as a note, so we would have capital N is equal to 100, right, on this 10 by 10 grid. We have randomly sampled 5 of those 100 objects. So if each object is essentially a square in the grid, we now have a sample of 5 of those squares. What the adaptive sampling scheme does is it says, if we randomly select a sample or a cell, in this case, so one of the squares, we then, and it has at least one maple tree in it on its own, then we move to the 8 neighboring cells, or, well, if you're in the corner, then you wouldn't be able to move to 8. You'd only be able to move to 4. But assuming that you're not in one of the corners, you then move to the 8 neighboring cells and you count the number of maple trees that are in those cells. So the adaptive aspect is that potential move from the cell that you started with to the neighboring cell, which only occurs if you find at least one maple tree in the original cell. Okay, so for example, our first cell is shown here. So it's the one marked in red with the number 1. So that's right here. Okay. All right, so we are saying in this case, or in this illustration, we're showing the situation where there is no maple tree in that cell. Okay, so there's no adaptation then, or no spread to the neighboring cells required, since we did not find any tree in this first cell. So we have m subscript 1 is equal to 1, which gives us y1 equal to 0. So y is the count of the number of maple trees, and m is essentially the sample size of the network that you are working with. And, well, rather, sorry, m is the size of the number of cells in the network that you are working with that contain a tree. So you can see we have m1 is equal to 1. Well, actually, that doesn't work in this case. So M1 is the size of the network you are dealing with. It is equal to 1 if there are no maple trees, and it is equal to the number of cells that contain a tree if there is at least one tree in the first cell. So there's some conditions there. So in the first situation, M1 is equal to 1 because we have no trees in it. Then we move to 2 here. Okay, so in this situation, you can see we have a red circle in the cell with the 2. The red circle in this case is going to indicate that a tree was found. So we found a tree in the originating cell. So then we branch out to every neighboring cell. So that's what the arrows represent. And then we search the neighboring cells for additional maple trees. So in this illustration, I've put 1 here above the number 2, 1 to the right of the number 2, and then 1 to the, I guess that would be southwest, if you will, of number 2. So that gives us 4 total trees. Hence, y2 is equal to 4. It also gives us m2 being equal to 4 because we're using 4 cells to count the 4 trees. Right. Now it's the same idea for the remaining situations. So you can see for number 3, we have 1 circle inside that box indicating we found 1 tree. We branch out to all neighboring cells, but in this case, we find 0 maple trees. So we have 1 tree, Y3, 1 cell, M3. Then we go to number 4. In this case, we're going to say again, we found 1 tree in the first cell. So then we branch out. Now in this case, you can see in 4 of the surrounding cells, we count a total of 14 additional trees. That gives us 15 total trees, hence Y4 equals 15, and M4 is equal to the number, M4 equals 5, which is the number of cells contributing a tree in this case. Okay, and then we go down to number 5, same idea again. So we're gonna say in this case, there's 3 trees in the first cell. So we branch out, and then in only 1 neighboring cell, we find an additional 4 trees. So we're using 2 cells to find a total of 7 trees in that case. All right. So this is an illustration of how the adaptive sampling scheme could work. Once we have our information collected, the estimation procedure is pretty much the same as it was in the other situations that we have seen throughout the course. But we'll go through those calculations briefly. As usual, I've decided to leave myself no room to do this, but I'll figure it out real quick lack here. Does anyone have any questions regarding how the process unfolds? All right, so if not, I'll just use this room on the side here to show how we would work through this process. It's going to be a bit tight. All right, so we have mu hat is equal to 1 over little n times the sum from I equals 1 to little n of yi over mi. So you can see that this is very similar to a ratio estimator in its form. So we're going to have 1 over 5 here. And then what we're going to have to do is take each of the different fractions that is associated with this measurement. So this would be, for example, 0 over 1 plus 4 over 4 plus 1 over 1 plus 15 over 5 plus 7 over 2. So that would be 0, 1, 2, 3. 1 plus 1 is 2, plus 3 is 5. 5 plus 7 over 2. 7 over 2 is 3.5. So 8.5 divided by 5. So that should be 2 points. No, that sounds a bit off. Let me just check this here. Okay, so that gives us 1.7. Right, and then we have variance of mu hat tilde. Okay, so this thing is going to be an FPC multiplied by this SY squared value over N. Okay. So I'm just going to move this one down here. Okay, so this is going to be 1 over 5 times divided by 100 multiplied by 2.2 over 5. And that gives us 0.418. And then, of course, from this point, we can do the usual thing. So we can use our variance to create the bound and then use the bound to find the interval for the estimate of the population mean number of maple trees in this particular area. All right. Any questions? All right, so if there's no questions, I'll just make a note here. So we'll say finish. Okay, so that'll be the end of new material for the course then. So with the remaining time, we have about 25 minutes, 35 minutes left, 35 minutes left. We'll start by doing some review for the final exam. The way that I typically run review sessions is I start off just by kind of going over what we've covered in the course so that you have a list of what's been seen. We'll break it down into components so you can kind of see what's been covered on each of the quizzes, what you haven't seen tested so far. And then from there, Again, we'll talk a bit about the structure of the final, what you can expect on the final, the resources that you have to get ready. And if there's any questions from anybody at any point, again, I'm happy to take those. And if there's any time left over, we can talk about some of the practice problems that were posted as well. So with that being said, I'm just going to switch over to this screen now. All right. Okay. All right, so this course, we've actually covered a lot of material this semester, which is nice. This is so I've taught the class 3 times, and this would be the second most amount of material I've been able to get through. So the first time I covered the most, the second time the least, and then the third time I was kind of in the middle of the two. So we got through all of the major components, and then we started to get into some of the extra stuff, which is cool. One of the things to keep in mind is this course, you can kind of summarize everything as estimate mu, tau, p, or pi via different sampling schemes. So the reason that I bring this up is the goal of the course is consistent essentially across all of the units that we talked about. So we've always been trying to do the same thing, which is estimate one of these 3 different quantities. Now, in doing that, we have actually studied, I guess it would be somewhere in the neighborhood of maybe 8 to 10 different techniques. I'll have a list momentarily that we can utilize to estimate these 3 quantities. And in doing that, we've also talked about properties of the estimators. Now, in the earlier material, we talked about this in quite some detail. So for example, with simple random sampling, we looked at very detailed proofs to show the properties of the estimators. With ratio estimation, we did the same thing. And then with stratification, that's essentially just a weighted SRS. So we didn't directly do the calculations of the variance being having the variance of the mean having the form it takes on, or the variance of mu being unbiased, but those are easy to show. And that same logic follows with a lot of the other approaches that we've talked about in the course. We've also deviated a bit in some situations and looked at how things relate to simple random sampling. We've talked about this idea of relative efficiency, for example. We talked about systematic sampling versus simple random sampling and how those 2 procedures are related. So there's a lot of in learning different techniques for estimating those 3 population quantities. We did branch off and go down different paths and talk about how the estimators that were utilized can behave under the different sampling schemes. Okay, so with that being said, one of the main objectives in terms of what would be the right word here, in terms of successfully writing the exam is identifying the sampling scheme. Okay, so one of the main things you have to be able to do on the final is determine what sampling scheme is actually being utilized depending on the information that's given to you. So in some situations, it might be data or summary statistics being broken down in a table. So for example, on assignment number 4, in question number 5, the way that the information was laid out was meant to indicate that you have a 2-stage cluster sample. So being familiar with how the data would appear if collected under the different schemes would be one of the ways in which you would be asked to identify what is happening. And this would probably be, in other situations, a fair description of the process that you would have to go through in order to identify which estimators you were going to use. So I can say that on the exam, there are other questions that would be similar to what I just described, in the sense that you're not told directly this sampling scheme was utilized to collect the information, but you are told that the data was collected and appears in the following way, and then you're shown either the raw data or you're shown summary statistics. So you have to effectively be able to determine which of the schemes has led to this particular set of information. Okay, so the difference on the exam, would we need to be given M bar in order for it to be known? This sounds like a very specific question. So are you talking about in the context of a cluster sample or a 2-stage cluster sample? I assume it's one of the two. Yeah, so I mean, the only way to know capital M, which is what I think you're trying to get at here, is to be told what capital M is. Okay, so, okay, how did we, what did we actually cover in the course? This is what I wanted to talk about next. So in this class, we've worked through only 7 lecture sets. So it's actually been a fairly condensed course in terms of the amount of PDF material that's been provided, but some of those lecture sets are very long, as you may or may not remember. So in the beginning, we just started off with basically like definitions, description of the sampling problem, we talked about estimators. Actually, this was in lecture set 2. Sorry. So we talked about definitions, description of the sampling problem, types of samples, and when I say types of samples in the early stage, I essentially mean the probability versus non-probability samples, right? So you might recall, for example, convenience samples, judgment samples. I think there was a couple of other ones. I can't remember off the top of my head what they were called, but we talked about these different types of non-probabilistic samples and the issues that can arise with those samples in terms of, mainly them being non-representative of the population. And then we talked about how a probability sample is designed to try and randomly survey from the entire population such that the resulting sample should have a balance of the characteristics that you would expect from the population that you were studying. And then we talked about the idea of how, like in a very simple kind of inside of a vacuum situation, if you have a population that is only determined by 2 characteristics for whatever reason, you could use like a quota sample in that case to collect the correct proportions of each of the different characteristics. But in the grand scheme, when you're dealing with a real world population, the number of features that define all of the different characteristics of that population are numerous. So there's many of these different characteristics. So trying to find the right balance of all of these to create a representative sample is typically and I don't want to use the word easier, but the probability sample is in some sense maybe more reliable to get towards that goal of collecting a sample that is truly representative. We also talked about errors and biases. Okay, so the first lecture set in the course was not mathematical. It was really setup, definitions, the types of things that you can expect to go wrong, the different general types of sampling schemes that we can utilize. And then also we talked about errors and biases. So again, the types of things that can go wrong and what to watch out for. Okay, in the second lecture set, we started with the actual mathematical stuff. So here we started talking about estimators, general sampling schemes, we defined the properties of estimators. And then we started to get into the main parts of the course. So then we started with simple random sampling. Okay. And within simple random sampling, we talked about, again, the main goal of the course, which was to estimate mu, tau, and pi. And then we also looked at the properties of those specific estimators. So we talked about showing that the mean estimator under simple random sampling is unbiased, right? So here we have estimates, properties. So we showed, for example, here, unbiasedness formula for variance, that kind of idea. Okay, and then we started talking about, in the same lecture set, we had systematic sampling. Oh, and I guess actually there's one other thing that I should mention here. A lot of this stuff will become repetitive as we work through this, but we also talked about sample size. Calculation. Right, and then this material to about here, give or take, this was what made up the first quiz in the course. So this is where we left off on Q1. I'm just gonna make sure, pretty sure about that. Yeah, and then quiz 2, we had systematic sampling and stratification. Yeah. All right, so in the same lecture set, we then started talking about systematic sampling. And within systematic sampling, we basically had the same discussion. So we talked about estimates, properties of the estimates. So those same two ideas that we had above. So we had estimates slash properties. But then we also talked about the true systematic sampling variance. We talked about periodic, ordered, and random populations. So we talked about how the SRS variance of the mean, the SRS estimator for the variance of the mean, how that relates to the systematic sampling estimator for the variance of the mean. And we've discussed how in each of the different situations, so periodic, ordered, or random, we can expect that estimator to behave. Okay, and then we also talked about something called repeated systematic sampling. Okay, and then within repeated systematic sampling, we also again had estimates, and we saw our first illustrations of what we call the ANOVA type calculations. Okay. Okay, and then in lecture set number 3, we had stratified random sampling. And within stratification, talked about a lot of the same ideas, but in talking about each of those ideas, so we have estimates slash properties. And then we also had sample size selection. And then I should have mentioned that up here as well, because we talked about how to choose the sample size and then use the sample size to choose the type of systematic sample. So like the 1 in K systematic sample, for example. Okay, but here we also talked about different types of stratification. Okay, so types of right, so we had proportional, we had optimal, and we had cost slash variance not constant. Okay, we talked about post stratification and double sampling. And double sampling. Okay. Okay, and then this is where quiz 3 went to. Right, so that's where we cut off on the second quiz. Okay, and then in lecture set 4, we talked about ratio, regression slash difference estimation. Okay, and then again, the idea here was that all 3 of these approaches shared the same goal as, like, just for example, all 3 of these approaches, ratio, regression, and difference estimation, they are not sampling techniques. They are approaches for estimating a population quantity. Okay, so in lecture set 2, we saw 2 sampling techniques. Okay, so this would be sampling protocol 1. This would be sampling protocol number 2. And this would be sampling protocol number 3. Right. So in lecture set 4, we don't have a new sampling protocol. We just have a different strategy for actually estimating the population quantity. So the goals here again are exactly the same. So estimate a mean, a total, or a proportion by including additional information. Now we saw these techniques within two of the protocols that we had already discussed. Okay, so here we have estimate mu tau pi, though I don't think we directly talked about estimating pi at any point. So I'll just write estimate mu and tau. Okay. And then we saw this within simple random sampling. Okay, and then we also saw this within stratification. Okay, so we saw these approaches in two different situations. And then I think I'm missing something on the formula sheet. I just noticed that I don't have a definition strictly for relative efficiency, but this is the lecture set 2 where we then introduced relative efficiency, which again is really just a comparison of the variances of the estimators that you were studying, right? So in general, the relative efficiency of E1 to E2 is equal to the variance of E2 divided by the variance of E1, right? So that's the general formula, and it changes depending on what estimators you're comparing. But the idea here was we now have a suite of different estimators that we can utilize to accomplish the same thing. So we can compare. So we have a ratio estimation approach. We know that we should use it because we have a correlated linear relationship that passes through the origin. But is there evidence that this ratio estimation approach is actually better than the simple random sampling approach? Well, one way that we can answer that is by comparing the variances of the estimator. So that's what relative efficiency is. So it's a fancy term for just saying compare variances. Okay, and then, oh, sorry, I actually went too far here. So so this is where quiz 2 ends, right? And then quiz 3 comes all the way down to the end of here. All right, whatever. All right, and then that takes us to the last main unit in the course. So here we have cluster sampling / two-stage cluster sampling. So these would be sample. Okay, actually, I'll just move this so it's not overlapping like that. Put it down here for now. And this would be sampling protocol 5. Okay, so within each of these units, again, we have the exact same goals. So estimation. We didn't talk about the properties of the estimators within cluster sampling as much, so we didn't go through a practice of showing it's unbiased or deriving the variance or anything like that. But in some situations, you can see, like for example, when you use the ratio estimation approach within cluster sampling or two-stage, you can see how familiar those are to the simple random sampling estimators. So the properties of those particular approaches are going to follow very naturally from what we had done before in the course anyways. which goes back to a point that I was making earlier on in the semester, which was effectively like simple random sampling is the basis for everything that we're going to see throughout the semester. So here we have estimation, and we have cluster size selection, or not cluster size, but selecting the number of clusters. All right. We had cluster sampling with equal sized clusters. And then that, I'll just put in brackets here, like this was the ANOVA style stuff that we talked about. And then we also had cluster sampling and stratification. Okay. I'll fix it after. Okay, and then we talked about two-stage cluster sampling, which was our next protocol. Same idea here again. So we had estimation, right? And we talked about estimation in two different situations, the same way we did with cluster sampling. So if M is known, if M is unknown. Okay, so via two approaches. Okay, sorry, I'm just trying to make sure I get all this written here. Okay, and then in lecture set number 6, we talked about sampling with and without replacement. And here we talked about empirical proof for unbiasedness. So we talked about how we can show that an estimator is unbiased underneath using those sampling schemes by working out those selection probabilities. And then in lecture set number 7, oh, and we also talked about cluster sampling with PPS. So that was a similar idea. So how does the cluster sampling adapt or change if we don't have an equal selection probability for all of the clusters? And then in the 7th lecture set, we talked about a number of different schemes. So here we have direct sampling, inverse sampling. Okay, and then both of these were for estimating capital N. And then we talked about density and size estimation. And then we talked about adaptive sampling. Okay, so you can see that based off of what we have seen, based off of the list here, the untested material is from lecture set 5 through lecture set number 7. Now we have seen assignment questions based off of lecture set 5. Okay, so this material here, cluster sampling and the two-stage cluster sampling, that was covered on assignment number 4. So the only things that you haven't been tested on directly are the stuff in lecture set number 6 and then those examples from lecture set number 7. As I had mentioned before, the final exam is a cumulative exam, but you can expect to see one question from each of those units that haven't been tested on the quiz, right? So you're going to get one question from lecture set number 7. You'll get one question from lecture set number 6. And then you'll get one question from lecture set number 5, I would say. I'm not going to test both 2-stage and I'm not going to test cluster sampling and 2-stage cluster sampling directly. That did get covered on assignment 4, but I'll ask something from lecture set number 5. And then the remaining questions could come from any of the areas that we had seen before. So there will be material from the previous sections as well, but you might not get one question from every sampling strategy. So stratification might not appear, for example, or systematic sampling might not appear, but one of the other units might, that kind of idea. There will be a mix of different style of questions. So you can expect to see at least one proof. You can expect to see at least one kind of compare contrast definition style question. And then the majority of the questions will be sort of those traditional, like compute the estimate, find the bound, discuss the properties of the estimator, the things that we have done throughout the semester. Okay, didn't leave a lot of time there. That took a little longer than I thought to go through. I'll post all of these notes afterwards, just like the lecture material and just like the video. Does anyone have any questions in the remaining time? Probably not 3 times longer. I found that the quizzes, I think most students with the quizzes, they were kind of like taking the full time period. It's weird because writing in an hour is more stressful, I think, than writing in 3 hours. But I think I'll have the final to kind of be like in the 2.5 hour range so that there's lots of time to submit online. If you're writing online, there's time to go over it. I mean, if you're prepared. Right? It's really hard to say because for each student, it's going to be a different experience. But I'm not going to try and make it stretch all the way from 9 to noon without any additional breathing room. And then just a reminder again, so the final is on Friday at 9. You can write on campus in 9-103, the same room we had the quizzes in. Or if you would prefer to write online for, obvious reasons, then that's fine as well. A number of students have already let me know. So if you've let me know and I've confirmed via email, you don't have to send another reminder or another email. This is just a reminder to the other students that are that need said reminder. All right, so I'll just say in closing then, I know that the winter semester was probably, like the fall semester was probably quite different for a lot of you. And, this is the environment is quite different from what we're used to at MacEwan. I hope that you still were able to find some value in the course. I know we got off to a bit of a rocky start there with that first quiz, but I think everyone has really improved on average since the first quiz. And I just hope that you guys had a good semester across the board, and hopefully in the fall we'll kind of be back to a more regular style of teaching and learning and whatnot. But just keep doing your best and good luck during your finals. And if you guys have any questions, please let me know. And otherwise, I guess I'll talk to some of you on Friday.